In this video, we're going to talk about the product rule and the quotient rule for derivatives. So we'll begin with this question. Suppose f of x is x to the fourth times natural log of x. Then what is the derivative f prime of x? Now, our first thought might be, well, we know what the derivative of x to the fourth is. It's 4x cubed, and we know the derivative of natural log of x is 1 over x. So maybe the answer is just 4x cubed times 1 over x. But it turns out that's not the case. That's not the correct answer. You can't just do a derivative of a product of two functions by doing the product of the derivatives. Okay, so how can you do a derivative of a product of functions? Well, we'll talk about the product rule in a second. But I do want to mention that it is true that the derivative of a sum of two functions is equal to the sum of the derivatives. So if f of x can be written as g of x plus h of x, so g and h might have some formulas, well, then to find f prime, we can just do the derivative of g plus the derivative of h. So in other words, the derivative of a sum is equal to the sum of the derivatives. And we've done this lots and lots of times. In fact, if we look at this example, f of x equals 2x to the fourth plus 7x cubed. Well, the derivative, f prime of x, is just going to be 8x cubed plus 21x squared. We did the derivative of a sum just by doing the sum of the derivatives. Okay, but again, that's not going to work for products or quotients. So I want to convince you that it doesn't work. So let's begin with this example. Suppose f of x is x to the fifth times x cubed. How can we find f prime of x? Well, the simplest way to do this is to just rewrite this as x to the eighth power, and now take the derivative. The derivative is going to be 8x to the seventh. Okay, and that's the correct answer. Now, a question we could ask, though, is could we get the correct answer just by doing, so we're going to put a big question mark here, could we get the correct answer just by doing 5x to the fourth times 3x squared? In other words, the derivative of x to the fifth, which is 5x to the fourth, times the derivative of x cubed, which is 3x squared. Well, notice what happens when we simplify this answer. We get 15x to the sixth power. Now, is that the same thing as 8x to the seventh? No. And we know 8x to the seventh is the correct answer because we just simplified it and took the derivative. So it turns out that this process of doing a derivative of a product by doing the product of the derivatives, that's an incorrect process. Okay, that doesn't work. Okay, so this is incorrect here. So how can we do the derivative of a product? So again, the derivative of a product is not equal to the product of the derivatives. So instead, we have this product rule. So the product rule says if f of x is g of x times h of x, then f prime of x is going to be, well, I think of the g of x as like your first function and your h of x is the second function. The derivative is going to be the first function, the g, times the derivative of the second, plus the second function times the derivative of the first. Okay, that's what the product rule says. The way you take the derivative of a product of two functions is do the first function times the derivative of the second, okay, g times h prime, plus the second function times the derivative of the first, right, h times g prime. Okay, so let's do this with the example that we had at the beginning of the video here. Suppose f of x is x to the fourth times natural log of x. What is f prime of x? Okay, well, in this function, we could think of it, if we were thinking of it in terms of g and h, the g of x would be like our x to the fourth, and the h of x would be like our natural log of x. But again, I don't even like to think of it in terms of g and h. I just like to think of it in terms of a first function, the x to the fourth, and a second function, natural log of x. Okay, so the way we take the derivative is to do the first function, x to the fourth, times the derivative of the second function, which would be 1 over x, plus the second function, natural log of x, times the derivative of the first one, which is 4x cubed. Okay, now this is perfectly fine as your answer. In fact, that is the correct answer. But often a book, if you're looking it up in a book or in My Math Lab, often they will simplify the answers. So we could simplify this answer by rewriting x to the fourth times 1 over x as just x to the third power. Okay, and then plus ln of x times 4x cubed. So this is a simplified version of the answer. In fact, you could even go a step further and notice that you really have two terms here. You have this x cubed, and you have this other term over here. Both of those have an x cubed in common, so you could factor out the x cubed and write it as x cubed times 1 plus, well, what we're left with over here is ln of x times 4, or 4 times ln of x. Okay, so any one of these three answers is the correct answer. But again, if you're doing the problem and you're checking your answer in a book or writing at My Math Lab and you're looking at the solution might look something like this. And you have to recognize that's really the same thing as this if you do a little bit of simplification. But notice that we found the correct answer not by doing the derivative of x to the fourth times the derivative of ln of x. We did it by using the product rule. Now, would the product rule work on this example that we just looked at up here? Could we do the derivative of this using the product rule? Yes, you can. Now, the easier way to do it is the way that we just did right here, but we could do the derivative using the product rule. So we could say f prime of x is the first function, x to the fifth, times the derivative of the second one, which would be 3x squared, plus the second function, x cubed, times the derivative of the first, 5x to the fourth. Okay, now this is the correct answer. If we simplify this, what do we get? Well, this first term would simplify to 3x to the seventh power, and the second term would be 5x to the seventh. And notice 3x to the seventh plus 5x to the seventh is 8x to the seventh. And notice that's the same answer that we got here. Okay, so the product rule actually worked in this example that we could kind of verify without using the product rule. We could also do it using the product rule, and fortunately, we get the same answer. Okay, now we had to simplify because if we just use the product rule without simplifying, our answer would look like this. But when we simplify, we notice that we got the correct answer. All right, let's do another example. Find y prime if y is equal to x cubed plus 7x squared plus 13 times e to the x. Now notice we have a product of functions. We have a first function here times a second function. So how do we do y prime? Well, we're going to write it as the first function, x cubed plus 7x squared plus 13 times the derivative of the second. Well, the derivative of e to the x is just e to the x plus the second function, e to the x, times the derivative of the first, which would be 3x squared plus 14x. And that is the correct answer. Now, notice we could simplify this. We actually have two terms here, one term here and one term here. Both of those terms have an e to the x in it, so you could factor out the e to the x and write it as e to the x times this plus this. Okay, in parentheses, this plus this. But let's just leave it the way it is. Now, the next example says to find dg dx, or g prime of x, if g of x is equal to x squared times the quantity x cubed plus 4. Okay, now again, here's another problem where we could do it in two different ways. One way to do it would be to simplify ahead of time. So we could rewrite this as x to the fifth plus 4x squared. Now notice I haven't done any derivatives yet. I've just rewritten what g of x is. And then we could do g prime of x by taking the derivative of this. This would be 5x to the fourth plus 8x. So that's one way to do this problem, would be to simplify ahead of time. But another way to do the problem would be to use the product rule. We could write this as the first function, x squared, times the derivative of the second. Now the derivative of this is 3x squared, plus the second function, x cubed plus 4, times the derivative of the first one, which is 2x. Okay, now again, this would be a perfectly acceptable answer here, but is it the correct answer? Do we get the same answer as this over here? And it turns out that if we simplify this, we'll see that we do have the same answer. In fact, notice this first term would really be 3x to the fourth plus, well, if we distribute the 2x here, we get 2x times x cubed, that's 2x to the fourth, plus, well, 2x times 4, that's 8x. And notice 3x to the fourth plus 2x to the fourth is 5x to the fourth plus 8x. So again, it's kind of nice to be able to do this problem in two different ways and realize that we get the same answer doing it both ways. So the product rule really does work. Okay, one more example with the product rule. We have a product of functions here, the first function times another function, and we want to take the derivative. So how do we do this? Well, first of all, let's rewrite this. So rewrite the cube root of x as x to the 1/3 power. And you could simplify this ahead of time. You could distribute the x to the 1/3 power here and do x to the 1/3 times x to the fifth, and you'd have to add the exponents, 5 plus 1/3. But then you're getting fractional exponents and adding fractions. So I think it's maybe just easiest to do this derivative using the product rule. So let's do the first function, x to the 1/3, or the cube root of x, times the derivative of the second one. So that'd be 5x to the fourth plus 1, plus the second function, x to the fifth plus x, times the derivative of the first one. Well, what's the derivative of x to the 1/3? It would be 1/3 times x to the minus 2/3. Right? Remember, if you have to lower the exponent by 1, and if we lower 1/3 by 1, we get -2/3. And let's just leave our answer like this. Now, what about quotients? Is the derivative of a quotient equal to the quotient of the derivatives? And it turns out it's not the case. Okay, it's not equal to the quotient of the derivatives. And a quick, easy way to see that would be to do an example. So notice if we have f of x is x to the 7th divided by x cubed, if we wanted to find the derivative, we could just simplify this ahead of time and write it as x to the 4th power. And then, so that's just what f of x is. Then f prime of x would be 4x cubed. Okay, so that's the answer. That's the correct answer to what's the derivative of x to the 7th over x cubed. Right? We just simplify it to x to the 4th and take the derivative. Is that the same thing? Okay, would we have gotten the correct answer if we just did the derivative of the top one, which would be 7x to the 6th, divided by the derivative of the bottom one, 3x squared? And it turns out no. In fact, this would simplify to be 7/3 x to the 4th power. Okay, and is 7/3 x to the 4th, is that the same thing as 4x cubed? No, right? It's not the same. So again, this would be wrong. So if you ever see a problem like this, you have a quotient and you're trying to take the derivative, you can't just do the derivative of the top divided by the derivative of the bottom. The derivative of a quotient is not equal to the quotient of the derivatives. Okay, well, how do we do the derivative of a quotient then? Well, we use the quotient rule. The quotient rule says this, and it actually looks a bit messy, but I'll give you kind of an easier way to remember this. Suppose f of x is a quotient of functions. It's some g of x divided by h of x. Then what's f prime of x? Well, it turns out it's this messy looking formula. It's the bottom one, h of x times the derivative of the top, minus the top one times the derivative of the bottom, all over the bottom one squared. Okay, now an easy way to remember this is if I think of the bottom one as like a low, we'll call the h of x the low, and the g of x we'll call the high, right? That's the low and the bottom, the high and the top. And if we think of d as being like a derivative, we can think of this as low d high minus high d low all over low squared, right? So low d high minus high d low all over low squared. So low, so that's the bottom function. D high, that means the derivative of the top, minus high d low, right? The top times the derivative of the bottom, all over low squared. Okay, so again, low d high minus high d low all over low squared. So let's do an example. How could we do the derivative of this? Okay, x cubed plus 5x over natural log of x. And again, notice we can't simplify ahead of time. There's no nice way to really simplify this ahead of time. So we're going to have to use the quotient rule. Okay, so f prime of x is going to be, well, low, which is natural log of x, times d high, so what's the derivative of the top, will be 3x squared plus 5. Now, you need to remember to put this in parentheses because it's not just natural log of x times 3x squared, it's times 3x squared plus 5. Okay, low d high minus high x cubed plus 5x d low. And what's the derivative of the bottom? Derivative of natural log of x is 1 over x. And that would be all over the low squared. Okay, and that is your final answer. Okay, and let's not simplify this here. You could simplify it, for example, by distributing this 1 over x times both of those terms. That would simplify kind of nicely. Oh, by the way, you cannot bring this 2 out front, okay, of the ln. You might think, oh, doesn't the power rule for logarithms say we can bring this 2 out front? No, that would only be if it were ln of x squared, right? If the 2 were inside the parentheses here. But if it's ln of x, that whole thing squared, that 2 can't come out front. Okay, so that's the answer. Let's do another one. Find y prime if y is equal to 7x minus 4 over x squared plus 1. Okay, how do we do the derivative of this quotient? Well, is the answer just going to be 7 over 2x? Right, the derivative of the top divided by the derivative of the bottom? No, that's not correct. We have to use the quotient rule. So y prime is going to be low x squared plus 1 d high. Now, what is the d high? Well, it's just 7. Right? The derivative of the top is just 7 minus high d low. The derivative of the bottom is just 2x all over low squared. Now, again, it's nice to be able to simplify these. Let's just leave the bottom part as just x squared plus 1 squared and not FOIL it out as x squared plus 1 times x squared plus 1. But how would the top part simplify? Because a lot of these problems in my math lab, you might have to simplify, or if you're looking at the solution somewhere, it'll give you a simplified answer. So let's distribute the 7 here, and this will give us 7x squared plus 7. We distribute the 7 to these two terms. And let's distribute the 2x to these two terms. Notice we have a minus 2x times 7x. That's going to be minus 14x squared. And then we have a minus 4 times 2x. That'd be a minus 8x. But notice this minus still applies to that. So it's actually plus 8x on the end. So you have to be careful with your signs. Now let's combine our like terms here. We have a 7x squared and a minus 14x squared. So that'll actually be negative 7x squared. And we still have our plus 8x on the top and still our plus 7 on the top. And this is all over x squared plus 1 squared. So if we simplify our answer, this is what we get. Okay, so this would be a non-simplified answer. And this is the simplified answer. But again, the process was just low d high minus high d low all over low squared. All right, now this example, our function is called s, and our independent variable here is t instead of x. So we're wondering what's the derivative of s with respect to t? Okay, what is ds dt? If s of t is equal to this. Now, actually, we could do this in two different ways. We could rewrite this as e to the t plus 9t, that whole thing times t to the negative fourth power, right? Because we're dividing by t to the fourth. It's like we're taking this and multiplying it by 1 over t to the fourth, but 1 over t to the fourth is just t to the minus fourth. Okay, and then we could use what? Well, we could use the product rule. We do the first function times the derivative of the second plus the second times the derivative of the first. So one way to do this would be to use the product rule. Okay, and I challenge you to do it that way. See what you get. Another way, though, is to use the quotient rule. So let's find s prime of t using the quotient rule. So s prime of t is going to be, well, low t to the fourth, d high. Now, what's the derivative of e to the t plus 9t? Well, the derivative of e to the t is just e to the t. What's the derivative of 9t? Well, it's just 9. Okay, so there's low d high minus, and make sure you put minus, not a plus, minus high d low. High is e to the t plus 9t. And the d low would be 4t cubed. And it'll be all over t to the fourth squared. And that is our final answer. Now, you could simplify this some. A couple things I want to mention, though. T to the fourth squared, what is that? Well, is that t to the sixth or t to the eighth? Well, if it were t to the fourth times t squared, that would be t to the sixth. But t to the fourth squared, that's t to the eighth power. Okay, and then you could distribute on the top this t to the fourth across these two terms. Distribute the 4t cubed across these two terms. Make sure you put a negative in front of both of them because of this minus. And then simplify, and you could get an answer that is a simplified version of this. Now, the last thing I want to mention is that this is low d high minus high d low. It's not high d low minus low d high. It's low d high minus high d low. If you do it the other way, if you did high d low minus low d high, you get your answer would be off by a negative. You get the negative, the correct answer. Because, for example, 3 minus 7, is that the same thing as 7 minus 3? No, 3 minus 7 is negative 4. 7 minus 3 is 4. Those would be off by a negative. So make sure you do low d high minus high d low all over low squared.